Welcome to Pre-Cal Trig, Lesson 3.05. We're going to be going over all the parts of an ellipse and some of the practice problems that you could see in the quiz. Get ready to take notes. There are formulas that you will need as you work through your second or third attempt on your quiz. So let's first talk about the definitions of an ellipse, everything that goes along with an ellipse. It looks usually like a squashed circle. So F, if you look here, F and G are called the foci. The foci of an ellipse are going to be inside of the ellipse. So we're going to have two foci, F and G, and for any point on the circle, we'll call this point P, the distance from F to P plus the distance from G to P is always going to stay the same, no matter where you pick a point on the ellipse. If you go from the foci to that point and you add those distances, they will always add to the same number. Another way to say that is that we travel the same distance when we go from point F to any point on the ellipse, and then we travel back to point G. There are 7 key parts of an ellipse. We have the center, labeled here with C. We have 2 foci, labeled in red with F, F1 and F2. We have 4 vertices, labeled here in green, E, A, D, and B. Now, the major axis is going to be the longer axis. So if you look here, the major axis is going parallel, or in this case, exactly on the x-axis. The minor axis is going from E to D. It's going to be the shorter distance. And when we talk about this semi-major, it's going to be half of the major. This is going to be the distance that we refer to as A. And the semi-minor axis is going to be half of the shorter axis. We also refer to that as B. The semi-major axis is half of the major axis, and the semi-minor axis is half of the minor axis. Take a look at that and make sure that you understand. The major axis is the distance all the way across. So when we're looking at the center, we're going to be going to the right or to the left or up or down from the center, the number of units that A or B will be to find the other coordinate. You'll see that demonstrated in a moment. So let's take a look at this again. The foci are F and C in this drawing. They're going to be inside of the ellipse. They're going to be a little closer to the center than the vertices. The vertices are A, B, G, and D. A, D, B, and G. All right, the major axis is going to be the longer axis. So that's going to be B, G. The minor axis is going to be the shorter axis, or AD. The center is right in the middle. That's point E. The semi-major axis is from B to E. Semi means half, half of the major, or EG. And the semi-minor axis is AE or ED. Make sure that we write down these formulas, and we need to understand the formulas define C, A, or B. It's always going to be C squared equal A squared minus B squared. But if you'll notice on an ellipse, the major axis is going to change based on whichever value in the denominator is larger. So A is going to always go with the larger number. So A and B, in other words, can change places. But remember, A is always going with the larger number. Okay, make sure that you have that written down and you understand the orientation. All right, here's an example. We're going to start by looking at the equation of an ellipse with the center at 0, 0. And the major axis is along the x-axis. So it's going to look something like this. It's going to elongate in that direction, horizontally. So x squared over a squared. And remember, this is correct because a is always going to be that larger number, and it's going to go with the major axis. This is going to be the smaller number, b will. So a is greater than b is greater than 0. And here's the formula again. B squared equals a squared minus c squared. Let's go back and check to make sure that that's what we had. Now we have c squared equals a squared minus b squared. So let's compare. C squared equals a squared. C squared equals a squared minus b squared. This gets confusing if you don't look closely. So to get this c positive, I can add it to both sides. We're just manipulating the formula. And we're changing the place of the b squared and the c squared. So this is the same formula. We've just moved the c squared to the left and the b squared to the right. And we get c squared equals a squared minus b squared. So if you need to put it in this form, you have the same equation. All right, so let's look at this equation in standard form. What is the center? The center is going to be at positive 3 because we're subtracting h. So that would make this a positive 3. And then k is going to be negative 1. Okay, when you subtract negative 1, that makes that plus 1. So it's going to be center is 3, negative 1. All right, what is a? Now remember, as I said earlier, a is going to always go with the larger denominator. So a squared is 9 and b squared is 4. Take the square root of 9 to get a. So a is 3. Take the square root of 4 to get b. So b is 4. Now let's use the formula. We can use the original one or the second one that I wrote. They're both the same. I'll just go back to the original. B squared equals a squared minus c squared. Let's plug in what we have. We have a squared and we have b squared. Okay, so b squared is going to go here. B squared is 4. That's equal to a squared, which is 9, minus c squared. Okay, so I'll go ahead and just subtract 9 from both sides. and I get negative 4 minus 9 is negative 5. Negative 5 equals negative c squared. Take multiply through by negative 1 or divide by negative 1 to cancel those negatives, and you get c squared equals 5. Take the square root of both sides, and because we're talking about distance, we're only going to be taking the positive. So c is equal to square root of 5. What that means is whatever axis is our major axis, we're going to be moving away from the center square root of 5 units. Okay, so we have an example here. The equation of this is at the center is at 0, 0, and the major axis is along the x-axis. So this equation is x squared over a squared. Remember, a squared is going to be the larger number. So a squared is greater than b squared, always for an ellipse. Now, this is not the equation that you see below. This is just the standard equation of an ellipse. So where we get that minus 3 that you see down here is when we move the center from the origin to 3, negative 1. So to pick out the center from the equation, if there's just an x squared and nothing else, then it's going to be at 0, and there's just a y squared, nothing here, 0, 0, origin. So moving away, we get to h, which is 3, and k, which is negative 1. So it puts it here. Okay, a is 2. We did this previously, square root of 4. Actually, remember what I said earlier. Let's correct this right now. I think this is what tripped us up. A squared is always going to go with the larger number, and b squared is going to go with the smaller number. So if we're looking for a, take the square root of 9, and we're going to get 3. If we're looking for b, take the square root of 4, and we're going to get 2. And then use this formula up here, or we could switch places with the a squared and the b squared, do your algebraic manipulation, and get a squared equals b squared minus, c squared equals b squared minus a squared. Okay, so I can just plug those values in. C squared equals 9 minus 4. So c squared equals square root of 5. We're going over what we went over previously, slowing down to make sure we understand that formula. So c squared equals 5. So if you take the square root of both sides, you get c equals square root of 5. Now let's look at how we graph the ellipse. The center is, we're going to pick out h from here, so x minus h. The center is positive 6, and y minus k. So to get a positive, you have to subtract a negative 3. Okay, now we need to find the endpoints. So let's look at the larger denominator, and that's going to be a squared. The smaller denominator is going to be b squared. Okay, so let's identify what a, b, and c are. So take the square root of 100 to get a. Take the square root of 36 to get b. And to find c, let's go back and look at that formula. C squared equals b squared minus a squared. C squared equals, did I do that right? C squared equals b squared minus a squared. This is where it gets confusing. C squared equals, it's always going to be the larger number. It's going to be a squared minus b squared because a is always the larger number. So it's going to be 100 minus 36. Okay, so if you get confused with what comes first, what you're subtracting, it's always going to be that larger denominator. Subtract the smaller denominator. So c squared is equal to 84. Wait a minute, let me get my calculator out. What is 100? That's not 84, that's 64. 100 minus 36 is equal to 64. Take the square root of both sides, and c is equal to 8. All right, the major axis is going to be with a, the larger denominator. So it's going to go up and down, the direction of the y. So we're going to take our center, and to the y coordinate, we're going to add and subtract 10. Okay, to the y coordinate. So we're going to leave the x coordinate alone. So negative 3 plus 10 is positive 7. Okay, and then we're going to leave the x coordinate. Negative 3 take away 10 is negative 13. Now for the endpoints of the minor axis, to the x coordinate, we're going to add and subtract 6. Because the x direction, or the x coordinate, that's going to be the smaller number. And we take the square root of 36, which is 6. We add that to the x coordinate, and we get 12. Leave that original center y coordinate here, negative 3, alone. So negative 12, negative 3. And then we're going to subtract 6 from the x coordinate, and we get 0, negative 3. Those are the endpoints of the minor axis. If you want to find the foci, okay, you'll add or subtract 8 from the y coordinate because the foci live on the major axis. So we're taking away and adding to the y coordinate. Didn't ask us for that here, but to graph it, I would include the foci. So to graph the ellipse, we have those 4 points that we found. These 2 vertices on the major axis and these 2 vertices on the minor axis. And we also have the center. So we plot those 4 points and then we connect. I'm not going to write those down. I'll just change my color and I'll circle them. So here's our center. We'll plot that point, and then these 2 points that we got by adding and subtracting 10 to the y coordinate, and these 2 by adding and subtracting 6 to the x coordinate. We'll plot those, and that's the 4 numbers that go down here, and then we'll connect those dots with the smooth curve. What is the center of the ellipse? So if you notice here, we don't have anything that we're subtracting from x, so that's going to be 0. And here, we have to subtract a negative 3. So it would be y minus negative 3 to give us y plus 3. So y is going to be negative 3. Okay, 0, negative 3, right here. All right, what are the endpoints of the major axis and minor axis of the ellipse? So we're going to find the length of each major and minor axis, and add that length to the x and y values of the center, just like we did previously. All right, so which one is going to be a? Remember, a is going with the larger denominator. So a squared is equal to 36. So a is equal to the square root of 36. We're just taking that positive value, or 6. And b squared goes with the smaller value. So b is going to equal to the square root of 12. So let's simplify that. I'll take 12 and I'll divide it by the smallest prime number, 2. 2 goes into 12, 6. Keep using 2 and then move up to the next number. Use 2 as long as you can. 2 goes into 6 3 times, and then we can't divide anymore. So we're taking the square root of a number. We need to take out pairs. So b is equal to 2 square roots of 3. Now let's use our equation to find c. Okay, so remember, c squared is going to equal to whatever that larger denominator is, a squared, minus the smaller denominator, b squared. So 36 minus 12. 36 minus 12 is equal to 24. So c squared is equal to 24. We're going to take the square root of 24 to get c. And c is equal to, let's do the same thing with 24 that we did with 12. It's going to be easy to see. 2 goes into 24 12 times. So we get that same ladder here. 2 goes into 12 6, and 2 goes into 6 3 times. So we have a pair of 2's. We can take out 2, and then inside we've got 3 times 2, or 6. So it's going to be 2 times the square root of 6. So we have A, B, and C. All right, now we didn't need to find C because it didn't ask for the foci. It just asked for the endpoints of the major and minor ellipse. So let's start with the center. We'll go back up to the top here and put the center. So the center is 2, negative 3. To find those endpoints, okay, A, find what axis A goes with. It goes with the y. So we're going to add or subtract 6 to the y coordinates. We're going to leave the x coordinate alone for now. So negative 3 plus 6 is positive 3. And the next endpoint is going to be negative 3 minus 3, or negative 6. Okay, now we're going to do the same thing for b squared. To find b, we got 2 square roots of 3. So we're going to add or subtract that to the x coordinate at this time. So these don't go together real nice because one's got a radical and one doesn't. So it's going to be 2 plus 2 square roots of 3. And we don't do anything to the y coordinate this time. We're traveling in the x direction. And then 2 minus 2 square roots of 3, 3. So those are our 4 points and our center. If we plot those, then we can make a quick sketch or a quick graph. Let me see if I did that correctly. I'm checking myself. Added 6 and then subtract 6. This should be negative 9, I think. 2, negative 9, 2, 3. All right, so see, it's easy to make mistakes, so go slow. Okay, there we go. All right, what are the foci? Now this time I need to always start off with the center. Okay, so the center, pull that out. X minus 2, the center is going to be positive 2. Y plus 1, y is negative 1. Okay, a squared always goes with the larger number. So take the square root of 49, and a is equal to 7. Okay, b squared goes with the smaller number. I'm not drawing that's a b. B squared equals, let me erase that. I don't think I'm going to ever get better at using these little pins and the mice, but here we go. Erase it, and let's put b squared equals 42. So b is equal to the square root of 42. Let's simplify that. So take 42 and divide by 2. It is an even number. So 2 goes into 4, 2. 2 goes into 2 once. And now we're going to move up to 3. Does 3 go into 21? It goes in 7 times. So we don't have any pairs. So we can't take anything out from underneath the radical. All right, so the foci are going to go along the major axis. And the major axis always is with the bigger denominator. It's a, or a squared. So we're going to add or subtract. We don't even have to look at b. We're going to add or subtract 7 to the x-coordinate to get the foci. So the first focus is 7 plus 2, or 9, and negative 1. And the second focus is, let's subtract 7 this time. 2 take away 7 is negative 5. And then we have negative 1. Okay, so those are our foci. Let's go on to the next question. We have the center of the ellipse, so we have H and K, and one focus is negative 6, 3. The major axis is 14 units long. Okay, so that's going to give us, half of that's going to give us A, because we need the semi-major axis. In other words, we're going to start at the center and go 7 units to the right and 7 units to the left to find the vertices. So we've got to divide the major axis in half to get the semi-major axis. So A is half of 14, or 7. Okay, and the major axis is always going to be the larger one. So we've got to figure out, we have one focus that's going to give us C, and it's going, the only thing that's changing is the X. From negative 9 to negative 6, what is the distance? Okay, negative 9, take away negative 6, or you can plot it on a coordinate plane or a number line and just count. But it's going to be negative 3. So the distance is absolute value. So C is equal to 3. So we have A and we have C. Okay, remember our formula, C squared equals A squared. A is always the larger one, minus B squared. The larger one always comes first so that we have a positive number. C is 3. 3 squared is 9. A is 7. 7 squared is 49, I think. Let me put it in my calculator just to be sure. 7 times 7 is 49, minus B squared. All right, let's switch places here. Subtract negative B squared and subtract 9. So we'll get positive B squared is equal to 49 minus 9. So B squared is equal to 40. Or B is equal to positive or negative Do we want the positive or negative? No. B is equal to the square root of 40. That gives us the direction that we go in, positive or negative, from the center to get the vertices of the minor axis. All right, now let's put this into words, what we've been doing. The center of the ellipse, this is our step 1. Okay, so the center is positive 6, negative 3. The endpoints of the major axis. Major is always going to go with the A. So let's put A squared here. Take the square root of both sides to find A is equal to 10. So remember, larger number defines the major axis. So we're going to add or subtract 10 from the y coordinates. We're going to leave the x coordinates alone. So 10 plus 3, oh, I'm sorry, that's a negative 3. 10 plus a negative 3 is 7. It's like 10 take away 3. Then negative 10 plus negative 3, those are both negatives. So we have negative 13. Now we're going to look at A. That's the smaller number. Oh, I'm sorry, B. B is the smaller number. So B squared is equal to 36 and B is equal to 6. So we're going to add or subtract 6 to the x coordinate to get the endpoints on the minor axis. So 6, let's take away 6 first. We get 0. Leave that y coordinate alone. Now let's add 6 to 6. 6 plus 6 is 12. And leave the y coordinate alone. Now you would graph those 4 points with the center and then make a smooth curve, and it's going to open up more in the direction of the y-axis. What is the center of this ellipse? We've been doing this all up until now, but all I want you to do is pick out the center. So our equation is x minus h squared. Right now, we're not subtracting anything from x. This would be x minus 0. So that x coordinate is 0. The h is 0. And then to get a subtract and get a positive 1, we'd have to subtract a negative 1. Right, what are the endpoints of the major and minor axis of the ellipse? So we're going to start off with the center. The center is at 2, negative 3. Now our a always goes with the larger number. So a squared is 36. And take the square root of 36. A is equal to 6. B squared, B always goes with the smaller number. So B is equal to the square root of 12. And if I simplify that out, dividing by 2, I get 2 times 2 is 4 times 3. We can pull out a 2. B is equal to 2 square roots of 3. All right, so I have A and B. I don't need to find C because I'm not talking about the foci. I have everything I need. I just need to add those and subtract those from the x and y coordinates. So first we need to find out from the center where the major axis is. It's with the bigger number. So to the y, we're going to add or subtract 6 to get the endpoints of the major axis. Okay, we're going to leave the x alone. So add 6 to negative 3, you get positive 3. Subtract 6 from negative 3, you get negative 9. Now let's find the endpoints of the minor axis. Minor axis goes with the smaller number, so we're to the x coordinate, we're going to add and subtract 2 square roots of 3. So it's going to be 2 plus 2 square roots of 3. And Go back to the center. We're not doing anything to the y this time. Negative 3. And then 2 minus 2 square roots of 3. And then negative 3. So we have these 4 points, major and minor axis, and we have the center. And you could draw a sketch of that. Now we want to find the foci. So let's look again and identify A and B. A goes with the larger denominator. So this is A squared and this is B squared. Take the square root of A squared of 49 and you get A is equal to 7. Take the square root of 25, B is equal to 5. Okay, let's take the center, identify the center. This is in standard form. So the center is going to be 2 and negative 3. The major axis goes with the larger number. So this is going to be the x coordinate that we're adding and subtracting 7 to get the 2 vertices. But that was the last problem. Look at this question. We're not looking for the vertices, we're looking for the foci. So now we need to find C. So C squared is equal to A squared minus B squared. A squared is 49, 7 times 7. B squared is 25, 5 times 5. Okay, take 49 minus 25. I'm looking for my calculator and I don't have it. Here it is. 49 minus 25 is 24. So C squared is equal to 24. Let's simplify the square root of 24. So we need to find C, not C squared. And let's divide that starting with 2. So 2 goes into 24, 12. 2 goes into 12, 6. And 2 goes into 6, 3. So we can take out a pair of 2's. We're taking the square root. And then we need to leave the 2 and the 3 under the radical. So this is 2 square roots of 6. So we're going to add and subtract 2 square roots of 6 to the major axis. So again, bigger number, going to add or subtract to the x. So our foci are the first one, call it F1, is 2 plus 2 square roots of 6, negative 3. And foci 2 is 2 minus 2 square roots of 6, negative 3. Okay, those are our foci. We only have foci along the major axis. Okay, now we have the center of an ellipse. So we have our H and our K. One focus is negative 6, negative 3. So if you do a quick sketch on a number line or a coordinate plane, negative 9 is going to be over here. Negative 9, positive 3, somewhere like this. Not real accurate, but you get the idea. If you're looking at the orientation, and then the other point, negative 6, positive 3 is going to be over here. So we want to know the distance. We're only moving in the x direction from negative 9 to negative 6. So negative 9 minus negative 6, how many units did we move? We subtract, we get negative 3. Absolute value, we moved 3 units to get from negative 9 to negative 6. Okay, so that's where one focus is. From the center to the focus, that's C. So C is equal to 3. The major axis is 14 units long. So from the center here, half of 14 is going to be all the way to the right and to the left. All right, so if we take half of that, we're going to get the semi-major axis, which is the number of units to the vertex. So that's going to be 7. So -9 minus -7 is, let's see, when we move over, we get -2. All right, so that looks right. If we go from -9, we step over 7, we're going to end up at -2. Okay, but that's A. A is 7. The only thing that we need to find, we have A and B, A and C, we need to find B. So remember, C squared equals A squared minus B squared. Let's plug in what we know. We know C is 3. 3 squared is 9. We know A, 7 times 7 is 49, minus B squared. Forgot to put the squared on the bottom. All right, now I'm going to move this over to the left. I'm going to add B squared to both sides, and I'm going to subtract 9 from both sides. Okay, so this is going to move over to the left. This is going to move over to the right. So subtract 9 from 49. B squared is equal to 40. Take the square root of both sides, and B is equal to square root of 40. Let's see if we can simplify that. All right, let's take 40, and we're going to divide by 2, and we get 20. Divide by 2, and we get 10. Divide by 2, and we get 5. So we can't take out the 2 times the 5. We can't take out the 10, but we can take out a pair of 2s. So this is 2 times the square root of 10. And that is B. B is equal to 2 square roots of 10. B squared is equal to 40. Why I didn't need to do that. Okay, because B squared, if you look at this, the major axis we drew this is going in the X direction. So that's going to be our A. A is 7. A squared is 49. B, we calculated that. B squared is 40, so that goes here. That's really all that we need. All right, let's move to the next one. All right, that's all that I have as far as examples. Do the best you can. Go back and look through your notes, but use this for help on your 3.05 assignment quiz. All right, get everything done by the deadline. Just do the best you can, guys. I'm rooting for you. Use the I can. If you don't know where that is, it's probably not helping not to know. Course lock date is on the 16th. Focus on Unit 1 test first.